Welcome to MyProjectBazaar.com. Let me discuss about the process achieving maximum energy efficiency in multi-relay OFDMA cellular networks, a fractional programming approach. Let me discuss about the abstract of the project. Efficient discovery and effective sharing of spectrum opportunities are the most challenging issues in a multi-channel cognitive radio network with multiple secondary users. Distributed opportunity spectrum access scheme based on sequential channel sensing in decentralized CRN cognitive radio network. Different from the traditional spectrum sensing scheme, the scheme proposed allows a secondary users to sense many channels one by one sequentially in a slot. Opportunity spectrum access based on sequential channel sensing in decentralized CRN. Simulated annealing is a probabilistic technique for approximating the global optimum of a given function. Specifically, it is a meta-heuristic for approximate global optimization in a large search space. It is often used when the search space is discrete. The SA heuristic considers some neighboring states of the current states and probabilistically decides between moving the system to states and staying in states. These probabilities ultimately lead the system to move to states of lower energy. This approach jointly addresses when to perform sensing, which channels to sense, in what order, and how long to scan each channel. About the flow diagram for our process. Initially, the system model has been designed. Consider an OFDMA DL cellular system relying on a single BS, M fixed RNs, and K uniformly distributed UEs. Cell is divided into M sectors. The cell is where each sector is served by one of the fixed RNs. Naturally, the path loss is a major factor in determining the receiver signal to noise ratio at the UEs and thus has a substantial effect on the EE. Therefore, in order to minimize the RN to UE path loss, all the UEs in a specific sector are only supported by the sector's RN, and therefore relay selection is implicitly accomplished, although the model may be readily extended to include relay selection. For the sake of mathematical tractability, it is not included in this work. The model accounts for both AF relayed link as well as for the direct link between BS and UEs, while the variables related to these two communication protocols are distinguishable by the superscripts. Energy efficiency maximization algorithm. Using the direct transmission protocol, the receiver's SNR at UE K on subcarrier N may be expressed, whereas when using the RF relaying protocol, the receiver's SNR at UE on subcarrier N may be expressed. Some other follows, where IAF or relaying protocol, the receiver's SNR at UE K subcarrier may be expressed. Finally, the weighted average SE of the system is estimated. For optimal power and subcarrier allocation, the optimal solutions are obtained based on the Dingell-Batch method. In this method, based on this method, we obtain the optimal solution. Performance analysis. Further, simulation results show that when there is insufficient power for attaining the maximum achievable EE, both EEM and SEM algorithms have the same solution. As the system's total power is increased, the SEM algorithm continues to allocate more power in order to achieve ever higher values of SE, whereas the EEM algorithm reaches an upper bound and does not make use of the additional available power. Additionally, a comprehensive study of the effect of various system parameters on the achievable SE and EE is performed. Let me discuss about the running procedure for our process. Select the main.file, the controller, right-click the file and run for executing this process. Here we perform energy efficient resource allocation and also subcarrier allocation for optimal power solutions. This algorithm executing based on the Dingell-Batch method. After performing the solution, we obtain the result. This is the average SE. This average subcarrier energy efficient allocation by varying the Pmax. Here we can vary the users, that is number of users. Here the users will be 30, 60 and 90. When users will be 30 means we obtain the curve like this, and when 60 means we obtain the curve like this, and when it increase to 90 means we obtain the curve like this. This is the average energy efficient graph for our various k values, and also by varying the Pmax. Here we obtain the k values for 30, 60 and 90, and this is the average energy efficient algorithm for by varying the Pmax variable. Here we can vary the subcarrier from n equal to 128 to n equal to 1024, and also n equal to 512. Finally, we analyze the energy efficient and also spectrum efficiency by using Dingell-Batch method. Thank you.